Good evening, guys. So today I'm going to try and introduce classes and functions as required. Like to do our assignment, we had to use classes and functions, and I know you guys have not been introduced to it. Some people might know it. However, of course, it's my role to discuss it, so I want to introduce it before we can proceed to our assignments. If the video is longer than 20 minutes, I want to post it separately. If it's less than, I may try and proceed with the assignment, but most likely I prefer to post it separately. Then we approach our assignment. So if we can successfully understand classes and functions, I'm not going to dig so deep, but I'm going to give you an essential framework on which to build upon to do our assignment. So you'll forgive me, my voice may not be so clear because I have flu, but let's start, right? So I'm going to create a new program. So I'm going to create a class. What's the use of classes, first of all? So classes are like containers we can use to store, should I say things? Or we can use them to, like, we can help categorize certain things in our main function. So if we assign like an object to a class, let me use an example of, all right, let me use Huda for example. So if, for example, I created a class called Muslim, and in my main function, in that class called Muslim, I said females, they must dress in long dresses, cover their hair, and so on and so forth. So in my main function, when I create an object called Huda, instead of me again assigning all those things to Huda, I'd be like, Huda is a Muslim, Huda is supposed to dress in a long dress, is supposed to wear Sharia, what that thing which they cover the heads and what. Instead, I can just be like, put for me Huda in the class of Muslims, and automatically the main function will know what to do with Huda. So when it's printing out or doing the program, it will deal with Huda as a Muslim girl or something like that. So I've already taken so long. Let's get into it. Let me create a new function. Let's save this as classes and functions.cpp, right? All right, so the first thing, let me do this. Don't forget, the first thing is you call out the input and output stream, tell the computer what you're going to do. Then we use the name space standard. We call the standard library. And then now this is where we put the classes. You put it behind here. So to put a class, I'm going to create a class. Let's call it, I'm going to call it rectangle. And this class is meant to compute, it will help us compute areas of different rectangles, right? So I'm going to call this class, and then I'm going to call it rectangle, right? So after creating the class, you open curly brackets like that. So there are two things. There's public, and then there's something called private. For now, I'm not going to dig deep into private or public. However, what you should know is private usually is when we don't want the user to over interact with our values, like putting in things like negatives and what. Instead, we give the user a chance to put in values, and we let our code sort of sort out what's real and what's not, and then give out what we would love. But for now, and we shall use it in our assignment. For now, I'm just going to use public. Public is like normal. Always make sure you put that. So we're going to create variables. We assign them to a data type of double, of length and width, right? Yeah, so I'm going to create, so I've created length and width, and I've said, let me increase, I know you guys may not be able to see. I've created length and width, and I've said, okay, what this means is, in my class called rectangle, I want to include two doubles, one length and one width, right? Then I close it like that. And then let me introduce you guys to functions, just real quick. I'm not going to make it very complicated. So now I introduce a function, what it should do with length and width, right? So I'll introduce, first of all, what will that function be dealing with? It will be dealing with a double. And this double, we can call it area, right? Area. So when you're creating a function, you put these two brackets like that, yeah, and then you put what you want this function to execute in the curly brackets, just like our main function. If you guys remember, you put int main, let me put it here, you put int and then main function, and then you start putting whatever you want inside here, right? So it's going to be the same thing. Let me remove this to prevent confusion. It's going to be the same thing here with our function. We put area, an area function, and then we put here the code we want to be done in this area function. What do we want to be done? I want it to calculate the area. So I introduce area. Let me call it double. Just for confusion, to avoid confusion, I'm going to put this area with a capital A, just so that it's not this, but you could as well put it as this, just because here it's a double inside, but it's, anyway, I'm going to use this just so that you don't get confused. So area is equal to, then I want this function, so I'm telling it inside this function there's something called area with a capital A, and this will be equal to length times width, right? So what this will do, and then I close it, and then what do I want it to do? I want it to see out for me after it has done that calculation. Area space, and then I want it to see out for me area, this area value, right? Should I put centimeters squared, meters squared? Yeah, let me put meters squared. Meters squared, right? And then I can end line, or I can just close it like that. For now, it's not so necessary. So I've created a function called area, and in this function it computes area, this length inside our class times this width, and then we go to our main function, right? So in the main function, I hope I've not put already so much content, because I'm seeing 10 minutes. I don't even know where they've come from. In our main function, I will create an object. Remember what I told you, that instead of me saying Huda is a Muslim, what, I just say in my class called rectangle that I created earlier, place for me an item. Let me call this item box. My favorite color is green, so I'm going to call it a green box, right? So I'm going to be like, in the class rectangle, I just call it as it is, like this. Now, it already knows that that's a class. There's some C+ apps that will like highlight for you and what. So it already knows that it's like how I said double. It knows that this is a data type. So this, it knows that, oh, there's a class. And I'd be like, put for me a green box. And then I close it. So when it's doing this, it already knows that in this green box lies in the rectangle. So he's about to start, telling me to refer to things inside here. So I'm going to be like, let me give the user a chance to let me print out enter length, right? Space. So I give the user a chance to put in for me the length of this box. So the length of this box, all we have to do now is inform it that the length of this box is just like the length in our class. But to do that, we first state the object. We'll be like, this object I told you has a length. So to call that, we place a dot. We'll be like, it has a length. So you can see here already, it has brought for me suggestions of what that dot can bring. So you can use this. You can just come here and press enter, but I'm going to type it manually. But you can just literally press enter. Let me show you. And it will bring exactly the same thing. So it already knows now what this is. It knows that this green box has a length, and this length is similar to what's up here inside our thing. So it knows that I'll be using this length soon. Then you're like, okay, print out, enter width, right? Enter width, then it gives the user a chance. So what shall we put here? I think you can guess. You state the object you created here, and then for that object, dot, what value are you putting in? So green box dot width. Then I can press enter and close. So every time the user puts this in, it will record that length inside here, width. And if we had a blue box and a red box, it will still fetch this, and it will bring out the output. For example, what do I want it to do? I want it to calculate for me the area. So now I'm going to call the function. Now, if you remember, if you can see, for me to call the length, what did I do? I wrote the object dot what I'm calling. So now to call the function, let me first put this down here. To call the function, I state the object, and you can guess what I'm going to do. Dot, you can see, I think here, it's already here. So I call the function. I can type it manually. It's always better for code practice. However, you could have just called it the way it is, right? So when I call this function area, it will be like, oh, what's inside area? Then it will know that there's a value area, which has length, green box's length, and the green box's width that I have to compute. And then after I've computed it, I print out the area and the value of what I've computed. I don't know if there are errors. Let's try and see what will come. Build, show me the error. Doesn't seem like there's an error, so run. If I enter length 2 and I enter width 3, Okay, I get 6 meters squared, so I didn't space this out. Next time better. Let's compile and run. So 2, 3, 6 meters squared. So I had to also put here meters and everything, but you know, I've been unserious. So for now, yeah, that's it. This will be the basis of what we do with our assignment. Basically, I don't want this video to be long. I shot an original video. It was 30 minutes, but the audio wasn't there. So I am not going to dig deep in this for now. I'll dig deep when I'm discussing this exact topic. But for now, this will be the basis of how we build our code. Now, since it's less than 20 minutes, I'm going to do our assignment technically, right? So I'm going to just close this. This means I'm not going to explain so much in our assignment. Sorry, not in our assignment, but I don't have to create 2 vids, right? So let me fetch our assignment. Let me just try and fetch our assignment. I don't know why it is the question. I'm looking for the question. I'm looking for our question. Where is it? Let me try here. Okay. Yeah, so here is our question. A structure member is subjected to axial loading developer program that computes stress, strain, deformation, and assesses behavior. So what technically we're going to do here is we're just going to first create a class, and in that class we shall always put members in it, our members which we're assessing, right? So in that class, we're going to compute stress, strain, deformation, and then it will use those values to check if the stress is greater than the material limits, right? The allowable stress. So technically that's it. I don't know what else. So when we go to the main function will just, what the main function will do is it will allow the user to put in the values, and then we shall assign that to an object, and the thing will remember the class and do for us the computation, right? So let's start our code for our assignment, right? So the first thing, we're going to create a class, right? Class, let's call this class structure. What's the spelling of structure? Structure member, right? So I'm creating a class called structure member. Then I open the curly brackets. No, not those, these. And then I start the business inside here, right? Let me do. So I'm going to first put a private domain, just so that the user doesn't disorganize our things. I told you guys I'm going to explain the private and public deeper later, but for now the private is so that the user cannot give us any, should I say nonsense? Okay, something like that. So I'll create force, then I'll create area, then I'll create length, then I'll create elastic. Should I call it Young's modulus? Should I call it elastic modulus? Let me call it Young's modulus. Shouldn't I call it Young's modulus? I don't know. Modulus. I want to call it Young's. I mean, kill me if you want to. Have to. All right. That looks very inaccurate, but whatever. It doesn't look official anyway. And then I'm going to create allowable. Should I call it allowable stress? Let me call it allowable stress. Right? Hope it doesn't confuse me during computations and everything. And then I want to now create my public domain. Don't mind these things up. Now this is what matters. Our most important code is going to lie inside here. I don't know why these are not in line, but whatever. So in my public domain, I'm going to create something called I want to recall the structural member, sort of creating a class. However, what I'm telling it here technically is I'm going to create from our class that we're creating, I'm going to create the ability to place inside everything that I need. So I'll be like double F. So let me show you guys what this would mean in our previous example. So if I had written, let's say like area, and then I did this, and then I'd be like double length. Sorry, my spelling of length is always messed up. I don't know. And then I'd be like double width, right? And this is kind of the same thing. The difference is when I'm computing area in the main function now, all I'll have to do is put length here. It will look something like this. I'll be like area. Don't mind the small a and what. I'm just showing you what it would be. I'd be like area 2, and then 6. And so it will take 6 as the width, and it will take 2 as the length. So that's what we're going to do here. And then it will compute. But I didn't do that in the other one because I wanted it to look more simple. Let's now do for this one. So I'm going to be like, in the class we created, structural member, allow me to place into these brackets what I would want you to compute instantly if I had. So I'll start with force, right? And then I'll go to the area, and then I'll go to the length, and then I'll go to the elastic modulus, right? What I called it, okay, length, and put this comma, and then allow me to put the elastic modulus and the allowable stress. I'm going to call it allowable, right? Don't mistake, allowable is not allowable stress. However, we're going to make it equate. Okay, let me not confuse you. Let me just start doing it. So when I put in these values, what do I want it to do? This is sort of a function. You can see here, the brackets, and then I'm like, what do you want it to do? So I create the curly brackets. When I put in these functions, I want you to equate for me force that I stated earlier in the private to F, right? And then it will know that this force is the force up here, and then I'd be like the area which I stated up, equate it for me to A, close, and then I'd be like the length. I know it may be a bit confusing, I've not explained so well, but just hang with me, you'll see how the code comes. I don't know if I'll make it below an hour, but I'm going to try because I've joined the vid, so it's going to be so long. But let's see, let me try and do it very fast. Then I'll have what should I call it? Young's modulus, right? So I'm going to have Young's, how did I spell Young's? Yeah, like that. Modulus. Young's modulus will equal to capital E. Close that code, right? So it's going to, it's like a small code. You may not know it, but it's like a very simple function telling you that every time I put in FALEL allowable, equate them to these as apthisms. It's simple. And then already we're now going to start putting in our functions to compute what we need. So let me look for our presentation, show you guys exactly what we might need. Oh, where did I put the presentation? Please let me get that presentation. Let me sort date modified, hope it restores. Yep, thank God. So technically what we need to calculate the stress, which will be the force out of area, the strain, force out of Young's modulus, the deformation, as in the question. If you can see the question, calculate stress, strain, deformation, assess the behavior. The assessment of the behavior is simply this: the stress we have calculated, check if it's below or above the allowable limit. That means the allowable stress. So you can see this. We're going to give the program the force, cross-sectional area, the length, Young's modulus, and allowable stress, and then it will compute everything, right? So let's get back to our thing. So we're going to start creating our functions, right? So there's a double, and I want this function to be, first of all, I'm creating a function that will be giving me a double, and I want it to calculate stress, right? Then I create this, and then I do what? I create the curly brackets, and then I'm going to put the function there. So when I tell it what to do, I want it to return for me the force out of area. Technically, I know you might be confused, but return force out of area, technically, unlike in the main function, in these sub functions, it just means print out for me force out of area, or like bring for me. We might use it elsewhere, but just bring it for me. And then what this function will do, it will compute force out of area and bring for you the value, right? Because it will bring for you a double that comes when you do force out of area. Then we're going to go to our next function. Our next function will be, what was the question? Wind pump, sorry. Stress, strain, right? So what is strain? Strain is stress out of elastic modulus, right? So let me create some space. Let me create more space down this end so that I'm able to code from up. So we have done that. Next thing, creating a function double calculate stress train. Remember, the user will put in for us the Young's modulus, so it's going to return for us what value? Strain is equal to stress out of elastic modulus, so it's going to be what we returned here, so it will be the value here, the value stored there, out of, the value stored in that function out of Young's modulus, right? Young's modulus, right? And then I close, and then we go to the next. I'd be like, I'm sorry for the spacing. I don't know why my computer does not space well. I don't know how I messed up things. I was trying to change themes and everything, and now I don't have any space whatsoever between my lines, anyway. So the next thing will be calculate. What are we calculating now? We're calculating the extension, elongation. So calculate elongation, right? Now what's elongation when you have all these values? Let me get to our presentation. I see the formula. Elongation, when we have all these values, will be, can also be called deformation, force times length out of area times elastic modulus, right? Jebrin corrected me here. This was strain. This was stress. Sorry for that. So I'm going to open the curly brackets. I tell it what to compute for this program, return, and then I'm going to put in everything. I'll be like, return. Now these brackets are not for a function, they're just brackets like how we put in a calculator. So I'll be like, return force times the force times the length out of, then I create more brackets, and then I'll be like, the area times the Young's modulus. Hope I'm getting the spelling of modulus right. Young's modulus. Okay. I hope it's not too long for you guys to hang on. You can always fast forward in front to see how things come out. But for now, I want to write our code from scratch, just so that in case you're like panicking and want to go through, you can go through it, though you can never go through it quickly because I'm not a very fast typer and I can't just type things without explaining to you guys why I'm putting them here. So after I've computed all those things, we're going to do that check which he talked about. So that thing I told you guys will be, we check if the stress is greater than the allowable limit, then it's okay. That's what he means by assessing the behavior, right? So we shall create a function, shall call it void. Usually when you're writing functions, you can use void to call. So check, again, I'll explain all these things deeper later. Void kind of just means call for me. It has deeper meaning, but let me not dig deep into it for now. But this function, it's not a double as such, because you're going to see it's going to print out things and what. It's not really going to calculate what, but still some voids also do calculate. But you know, let's check. So let's check the safety. I think let me call it that. And then, by the way, I've not saved this. Saved it as classes and function. And the good thing I already have the code, so this is just to explain to you guys. So I'm going to check the safety, and then I'm going to create something called stress. If you notice, we're calculating, computing, but we have not really created a variable called stress here. So this is allowable stress, not stress. So this is the first time stress comes in. So a double called stress. What's the stress? The stress is equal to the value returned in this function. I'm going to try and do this as fast as possible so that it's below an hour, but I don't think there's any chance it's going to be below an hour, but I'm going to try my best. So the value returned in that function here up, this is what stress will be equal to, right? Then I'm going to use if. I don't know if I've not introduced you guys to the if statement. So if technically means if the if function is like if what's inside here is correct, execute for me a program here, right? Or else execute the program here. Again, my example is always wood. I don't know why. So maybe let me use another example. Let me use Professor Paul. So it's going to check what should I say is to be checked, what is executed if true, what is executed if false, right? You can see, right? So what I've already removed this. You've read what is here. So if it checks this and it's correct, it will execute this. If not, it will execute what's inside here. If there are more than two conditions, there will be something called if else. If else, it will be something like this. If else, you can see, right? So let me show you just a small example very quickly, very quickly. So if, again, it's like a factory or something, right? Let me use Huda. I'm not going to use Professor. So if Huda is, let's say it's a factory that dresses, it's just a dressing always. If Huda is a Muslim girl, dress her in a Sharia. These are very wrong spellings. I don't even know what this means, but I've heard of it, so I want to use that so that you guys understand. Or else dress her in cargo pants. So if this factory machine, whichever machine it is bringing Huda, let's say on a conveyor belt, and it checks and it's like, oh, this is a Muslim girl, it's going to smash on her that Sharia, cover her hair and whatever. But if it finds out that no, Huda is not, again, I'm using her and I'm wrong. Why is that the spelling? I don't know. Whatever. So if it finds out that Huda is not a Muslim, she's actually called Huda's man, Jen. If it finds out she's not a Muslim, it's going to bang her. It's going to put on her cargo pants, right? I think you've understood that. So let's get back to business and do the if now. So here what we're going to do if stress, this stress value this stress value of ours, right? If stress is greater than, is greater than, space it out, allowable, what did I call it? How did I call it? I called it allowable stress, right? So if our stress is greater than allowable stress, do this for me. Open curly brackets, put in the code to execute what we wanted to do. If it's greater, we'll be like, print out for me the material stress. If it's greater, material will be like material stress exceeds allowable limits and can't be used. I don't know if that's, is there anything like material stresses? Does that make sense? But whatever, can't be used. Yeah, so it will print that out. I'm going to end the line, and if not, what will it do? It will do this. If that's not the case, it will print out the material is safe for use. Full stop. Here and then put an exclamation mark, just to show danger, right? Okay, 145. Material is safe for use, end line. Done, right? So after this, what will happen is it will check, it will get this value, check what our user has put in, and if the user has put in let's say the allowable stress and everything, it will do that, it will show that. Now let's create something, another function that prints out for us the results, like what we have calculated. Call it display results. Display results. So here I want it to print out for me. To start a new line, I'll press / new line. If you want to end the line using this format, you / end line, right? So I'm going to print out on a new line, final results. You can always design this how you want. I like spacing it out a bit like that, just plain. I want it centered, sort of. I end the line there. I can end the line like that, or I can end line like the traditional, but I'm going to end it like that. Then I want it also to print out the value of stress, right? The value of stress. What do I want it to print out? I want it to print out what it computed in this function. Remember this function, and then I want it to be in Pascals, so I'm going to just be like, give it some space and then Pascals, no full stop needed, and then I end the line. And then another thing I wanted to display for me, I wanted to print out the strain. Strain is a ratio, so it won't have, what did I call this thing? I called it calculate strain or calculate elongation. Oh, calculate strain. It's not the extension, so it's not. I'll end it. It's just what? Ratio, so it won't have any units. And then we shall see out the elongation as required by the question. Elongation space. Then I wanted to print out what it calculated, what it returned in this calculation. I called it what? Elongation. What did I call it? Elongation. Oh, but I did it with a small. Oh, big. All right. So elongation, what it returned here, but elongation is in meters, space meters, and then I end the line. And then when it has done all that, printed out and shown us those values, I'm going to call this, be like, for these values, check for me, how safe is it, and then do what happens inside there. So I'll be like, check. Because I'm within the class, I don't need to recall, like how I told you, an item, then not really, that will be in front. So I just be like, use the function above. So because we're still in the same class, it will just do the safety check real quick, and then we jump to our main function. What our main function is basically going to do is help the user put in the details, right? So what do we want the user to do? We create the variable, right? The one we're going to use for them to place in. So I'm going to create double capital F, A for the area, L for the, this will just be to enable the user to put in the values. Young's modulus, is it young? Use small. Young's, this video would be shorter, but then because I type slowly, it tends to be much longer. And then the allowable stress, allowable stress. Remember these values, all these things. Force area, I've not put length. Coba, all these things are where the reasons we're going to assign them to this, so don't worry about them, right? So our next thing we shall do, we're going to give the user a chance to put in these values, right? So it shall be like cout enter force. Force in newtons. Enter force in newtons. Then the user can put their value of force, right? So we let them put in force, close, and then we cout enter cross-sectional area. space. I'm not going to speak much as I'm doing this. What should they put? The area. And then print out. What else do we need? We need the length. So I'll be like enter. Sorry. Enter length. So when they enter the length is in meters, remember. Give them some space, and then they will see in the length. Close, and then print out. Enter. What else are we left with? We don't have Young's modulus, so I won't put enter Young's modulus. It's in Newton meters. Newtons per meter. So I'm going to use Pascals. And then the enter space, give them some breathing space always, and then they'll see in. What will they see in? Young's modulus, right? And then what else will they put in? I'm going to allow them to put for me finally the allowable limit, right? Enter allowable stress of this particular material. And then they'll put for me the allowable stress. It's also going to be in Pascals, I guess. I don't know. We can only hope. It's meant to be in Pascals. So it will give us the allowable stress. You remember this? I hope it doesn't bring errors. So after I've done that, now the next thing we're going to do in all this, we're going to call our function like how I told you guys. So we're going to create an object. I'm going to create an object called member, but I'd be like, in the class I created up here, you remember, in my class called structure member, place for me an object called member. And in this object called member, allow me to place in these values. Remember them? A, L, and Young's modulus. Young's modulus and allowable stress. Right? So this member means in this member allow me to place in these values. How I told you that I could put them in here. So when I put this, you know what to do. I want you to calculate for me. When I create this member, for this member call for me, I can use now any of these functions, right? The one I want is display results. That. And then I close, and then I return 0. Now I know there are going to be so many errors. I'm going to try and fix them. Let me check now. I build. So here they're telling me there's an error. Before double was not declared. So you're going to give me 1 second and I'm going to try and rectify these errors so that I don't take so much time. However, don't panic, right?